This video is related to the Edgenuity lesson, right triangle similarity. So what they talk about in this lesson is how if you have a right triangle, so like this giant right triangle here, and you draw an altitude connecting the right angle to the opposite side. That just means you draw a line that makes another right angle to the opposite side. You end up with three similar triangles. So you have the big one, the medium size over here on the left, and then for this one, the small one is on the right. So there's 1, 2, 3 whole triangles here, and they are all similar. So that means their side lengths are proportional. So to give you kind of an idea of what's going on, I have these color coordinated triangles right here. So what happens is if we draw, this is the small triangle right here on the left, or excuse me, on the right. This is the medium triangle that's on the left. I just drew it standing up. So there's the small side, the long side, and the hypotenuse is orange. And then you have the giant big outer triangle that I also drew standing up. So if you notice, like the length of the medium hypotenuse is the same as the length of the longer leg of the giant triangle. So that's how we're going to set up our proportions. So some of the lengths are overlapping. Or also, for example, the shorter side of the big triangle is the same as the hypotenuse of the little triangle, because those are the parts that overlap. It's the hypotenuse of the little guy, but it's also the short leg of the big guy. So if I fill in what I have, 5.5x, 3.1 here, and this whole length here is 6.3. So if I fill that in here on my triangles on the right, the purple sides are 3.1. So there's a purple side, there's a purple side. The blue side is x, blue there and there. The orange side is 5.5. And the whole length down here is 6.3. So this giant hypotenuse, red and green, is 6.3. Whoops. So from there, we're going to set up a proportion. So we need to use things, sorry, there's a glare there, where we have lengths for both. So what I mean by that is like here on the small triangle and the large triangle, we have the long legs and we have the hypotenuse. So these are the triangles we're going to use to set up our proportions. This guy, we could use it, but I'm going to go ahead and choose to use the little guy because look, we have x and 3.1 and 5.5 and 6.3. So either one would work on this one, but I'm going to go ahead and use small and big. So long leg is to long leg here, as hypotenuse is to hypotenuse here. And then to solve proportions, all we do is cross multiply. So x times 6.3 is just 6.3x. 5.5 times 3.1 is going to be 17.05. And then divide both sides by 6.3. And x is 2.71 there. So that's how you solve for that length. Now let's look at another one. Let's say that you don't have this at home, or you didn't make, what you could do is pause the video right now and make, get some markers out and make these. So that is my drawing here. But let's say you don't do that and you just have a picture like this and you're trying to figure out what y is. So what I suggest you do is go ahead and draw out, just kind of like I did here on this, the three triangles. So the little triangle, the medium triangle, and then the whole big triangle. And then from there, it's easier to set up for your proportion. So looking at the little triangle, this is what I call the short leg. This is the medium leg, and then the hypotenuse is always the longest, but we call it the hypotenuse. So I know the short leg of the little triangle is 2. I always put the short leg on the bottom. And I know the hypotenuse of the little triangle, because that's opposite the right angle, is y. On the medium triangle, all I have is that this long leg here is 5. On the giant triangle, I know that the short leg is y, so I'm looking at this whole big thing here. The short leg is y, and the hypotenuse, opposite the right angle, is this whole length, which is 7. So the medium triangle, I only have one length there, so that's not going to help me out at all. But here I can write a proportion. Short leg is to short leg as hypotenuse is to hypotenuse. So short leg is to short leg as hypotenuse is to hypotenuse. So if I cross multiply here, I'll have 2 times 7 equals y times y. So 14 equals y squared. And then to undo squared, we just square root both sides. There are no perfect squares that go into 14, so we're just going to leave it like that. Y equals the square root of 14. The other thing that they talk about in this lesson is geometric mean. And when we use this, it's when you have the hypotenuse of the big triangle. Okay. The hypotenuse of the big triangle is broken up by the altitude. So it's only when you're breaking up the giant hypotenuse here. And the way you set up the geometric mean is outside over inside equals inside over outside. So out over in equals in over out. That's how I think of it. Out over in equals in over out. Out over in equals in over out. And then that's how you would set up the geometric mean to solve this. So if I cross multiply, and then we square root both sides to get x by itself. Now for 12, there is a perfect square that goes into 12. It's 4 times 3. So I can break that up and get a final answer here of 2 root 3, because the square root of 4 is 2. So similarly here, we have the giant hypotenuse is broken up by the altitude, the giant hypotenuse. So I can go outside over inside equals inside over outside. Again, there's a perfect square in 24. So we end up with 2 root 6.